f1 focal length of the first lens, f2 focal reciprocal of focal length is called power, and it is inverse at a distance v from the center. So v qi emergent ray. So this is curvature R1 A D C with radii of curvature. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Thought for the day: the greatest achievement in life is not to say that I have never fallen down, but the crown is to say, whenever I fall down, I rise hard. So students, continuing my discussion today, we deal a very important bookwork, something called Lens Maker's Formula. Please to understand, there cannot be a second year question paper in physics without Lens Maker's Formula. A very, very important expression. I want you all to note, understand and practice each step of this derivation. So we start doing something called Lens Maker's Formula. As I told, a very important derivation that is asked for 5 marks. Lens Maker's Formula. ಕನ್ನಡದಲ್ಲಿ ಇದನ್ನ ಮಸೂರ ನಿರ್ಮಾಣಿಕನ ಸೂತ್ರ ಅಂತ ಕರಿತೀವಿ. ಲೆನ್ಸ್ ಅಂದ್ರೆ ಮಸೂರ, ಮೇಕರ್ ಅಂದ್ರೆ ನಿರ್ಮಾಣಿಕ, ಫಾರ್ಮ್ಯುಲಾ andre sutra. Lens Maker's Formula, which is actually called Masura Nirmanikana Sutra. Now, we go to the considerations of this derivation. I consider a convex lens. What type of lens am I using? Convex lens of refractive index N2, which is placed in a medium of refractive index N1. So if you observe the diagram, students, this is the convex lens. Be very clear about the lens. Convex lens of refractive index N2. The lens is made of glass which has refractive index N2. It is surrounded by air which has refractive index N1. So convex lens of refractive index N2 surrounded by air which has refractive index N1. This is important now. Please to understand. ABC and ADC are the two refracting surfaces of radii of curvature R1 and R2 respectively. Now, the lens has two refracting surfaces. ಈ ಲೆನ್ಸಲ್ಲಿ ಎರಡು ರಿಫ್ರಾಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ಗಳಿವೆ. ಮೊದಲನೇದನ್ನ ABC ಅಂತ ಕರಿತೀನಿ, ಎರಡನೇದನ್ನ ADC ಅಂತ ಕರಿತೀನಿ. ಸೊ two refracting surfaces, which are they? ABC and ADC respectively. R1 is the radii of curvature of the surface ABC, and R2 is the radii of curvature of the surface ADC. So what is the nature of the lens? Convex in nature. Two refracting surfaces ABC with radii of curvature R1, ADC with radii of curvature R2. Now, O is the point object which is placed on the principal axis at a distance u from the center. So O is the point object, a very small object which is placed on the principal axis at a distance u from the center of the lens. So u is the object distance. OP is the incident ray. PQ is the refracted ray, and QI is the emergent ray. So which is the incident ray? OP. Refracted ray PQ. Emergent ray QI. And I is the real image, not the virtual, real image of the object O at a distance V from the center. So V is treated to be the image distance. So my considerations are very simple. What type of lens I have used? I have used a convex lens of refractive index N2. How many refracting surfaces it has? Two surfaces, A, B, C, whose radius of curvature is R1, ADC, whose radius of curvature is R2. O is the object, U is the object distance. I is the real image. V is the image distance. OP incident ray, PQ refracted ray, QI emergent ray. So this is the basic considerations I have taken up to analyze lens maker's formula. Now going to the mathematical part, the formation of this image can actually be considered in two steps. Ili image I ide alva, adra formation ಎರಡು ಸ್ಟೆಪ್ಗಳಲ್ಲಾಗ್ತಿದೆ ಅಂತ ಅನ್ಕೋಬಹುದು. So for my mathematical convenience, I believe formation of the image is happening in two steps. The first one, refraction through the surface ABC. In the first step, I am considering the formation of the image when I consider refraction through the surface ABC. Or the other way, it is to understand that the surface ADC is absent. Very beautiful. I am considering refraction only through the surface ABC, which means the other way, the second surface ADC is absent. Meaning to say, see, the second surface ADC is absent. ADC present illa. Now, OP is the incident ray. Now, PQ, observe, ADC is absent. Can the light now bend and can the image be formed at I? No chance. Why? The surface ADC is absent. There is no presence of ADC. Light cannot bend at ADC as it is not considered. So what should happen? Now light has to travel straight and the image has to be formed at I dash. So very clearly you see, OP is the incident ray, ADC is not present, light travels straight and now the image is formed at I dash at a distance V dash from the center. This part of the lens is absent. So now students, I dash is the real image formed at a distance V dash from the lens. Now, considering refraction through a spherical surface, In the previous session, I have derived an expression for refraction in the spherical surface minus n1 by u plus n2 by v equals n2 minus n1 by r. This was the equation that we derived in our previous session. Now, what is n1? Here n1 is the refractive index of the medium in which the object is placed. So, we also call n1 as the object space refractive index of the medium in which object is placed. In my situation, the object A is placed in air. Lens ಒಳಗಡೆ ಇಲ್ಲ, lens ಮೇಲಿಲ್ಲ. Object is placed in air medium whose refractive index is n1. So minus n1 plus n2 image space. Oh, ಹಾಗಾದ್ರೆ ಏನದು? Medium in which image is formed anta. Here again, image is formed in air. ಆದ್ರೆ n2 ನೇ ಹಾಕಿದ್ದಾರೆ? No. Image space ಅಂದ್ರೆ it is the refractive index of the medium which is causing the image. ಯಾವ medium ಇಂದ image cause ಆಗ್ತಿದೆಯೋ, image form ಆಗ್ತಿದೆಯೋ, which medium is creating the image, that is what we call as image space. Here, light is incident on the lens, emerging out, and the image is formed. So, who is forming the image? Lens of refractive index n2. U object distance. So, here object distance is u. V image distance. Now, image distance is v dash equals n2 minus n1, and the radius of curvature for the first surface is r1, and I call this equation 1. Again I repeat, n1 object space refractive index of the medium in which the object is placed, n1. Image space refractive index of the medium causing the image, lens n2, object distance u, image distance v dash, n2 minus n1 by r1. So this is refraction through ABC. Next, refraction through ADC. So, refraction through the second surface ADC, which means to say, now the first surface ABC is absent. So, when I am considering refraction through the second surface, I mean to say I am considering that the first surface ABC is absent. Here I have a beauty. If I imagine that ABC is absent, then what about the incident ray and what about the object? A, B, C is absent, then can O behave as the object? Ray of light from the object has to be incident on the surface, then refraction has to happen, then formation of the image. But principally here, the surface ABC is absent. I don't have an object. Then from where will I have formation of the image? To understand that, I am considering I dash as virtual object. Formation of image ge object beke bekagutte. So I am considering I dash as virtual object which is at a distance V dash from the center. And I is the real image. Now I is the real image formed at a distance V. So here in this case, because I have considered ADC is absent, I dash behaves as virtual object at a distance V dash from the center. I, by the previous description, since you have ADC, is the real image formed at a distance V. Now, again considering the same formula, object space, but my image or I dash is the virtual object. So I assume N2 now is the medium carrying the virtual object. So N2 object distance V dash plus I is the real image. Again, who is causing the real image? It is the lens ADC. So N2 by V, because the image distance is V, equals N2 minus N1 by minus R2, refractive index of ADC. This is by convention. So only thing you understand, here N1, that is the refractive index of the object space, is taken to be that of the lens itself, because the object is a virtual object which is carried by the lens. Now, simplifying equation 1 and 2, minus 1 by V. When we simplify, this turns out to be minus N2. So N2 I take out, 1 by V minus 1 by U. N2 in the numerator taken out, 1 by V minus 1 by U. N2 minus N1 taken out in the numerator again. N2 minus N1, 1 by R1 minus 1 by R2. Or dividing throughout by N2, minus 1 by U equals 1 by V. N2 by N1 minus 1, 1 by R1 minus 1 by R2. So I have divided throughout by n1. And therefore here, if we observe, the numerator is n2 by n1. So this is n1. Now we have a formula called mirror formula, which says 1 by v minus 1 by u equals 1 by f. Or here n2 by n1. N2 is refractive index of glass, which is n. N1 refractive index of air, which is 1. So 1 by f is n minus 1, 1 by r1 minus 1 by r2, and this is the famous lens maker's formula. As I told, this is often asked for 5 marks, so please do understand. Now we study a concept called power of a lens. This is always asked for 1 mark. Mathematically, power of a lens is defined as 1 divided by focal length. Reciprocal of focal length is called power, and it is inversely related to focal length. Therefore, we say SI unit of power is diopter. Again, 1 mark. The SI unit of power of a lens is diopter, and power of a lens is 1 diopter when the focal length is 1 meter. 1 diopter when the focal length is 1 meter. This is an assignment for you all. Exactly as we derived an expression for lens maker's formula, we have expression for focal length when 2 thin lenses in contact. So 1 by f is 1 by f1 plus 1 by f2. F, focal length of the equivalent lens. F1, focal length of the first lens. F2, focal length of the second lens. Or 1 by f is P. This can also be written as P1 plus P2. So students, in my today's session, we have arrived at lens maker's formula. We have studied something called power of a lens and equivalent focal lengths of thin lenses in contact. So we'll continue in the next class. Until then, have a nice time. Thank you.